a lot. You know, because I think it is. You're right. It's a form that you can let your imagination wander and address things without restriction.
Did you like Alien too?
I saw Alien. When I was at school, it was 1979, and we had a school film club. And in the 70s, they weren't like they are now, you know. So the first film, after 3 films, I was 11, and it was Alien, Apocalypse Now, and Life of Brian, which so that was
Oh, those are 3 great choices. But I feel like Ridley Scott's original Alien is probably one of the greatest horror science fiction movies of all time. One of my all-time favorite movies. But I really like the newer ones as well. Like I like Prometheus, and I really like Covenant, the last one.
Yeah, Prometheus. I don't know.
It's not the best one.
I
But
love
I kind
the
of like what they're trying to do with it. The whole idea about the engineers coming back in time, and
that's why I was disappointed with it, because I thought the opening was brilliant, and I thought this is just going to be brilliant.
Right.
And then I thought it just lost its way, and it was a disappointment because it could have been so brilliant.
Yes, I agree with you. Yeah, the beginning was fantastic, but I think Covenant was more exciting, and it's also preposterous. Like if you went, like the last thing we'd be doing is just breathing in the air, right? I mean, we'd have to be really careful. If there was life on the planet, we'd have to be really careful to contaminate, but be.
Yeah, I mean, there's also, I mean, you know, the other thing in science fiction films is gravity, because even in Alien, you always just say the spaceship has gravity. Again, there's only 2001,
right,
where everybody floats around.
Yeah,
because has a spinning thing.
Right, the spaceship has gravity, and then when you land, the gravity is exactly like Earth.
Yeah,
perfect.
Yeah, but
it's ridiculous. Yeah, I mean, what are the odds that you would find a planet that is exactly 1 times the size of Earth? It would have far more gravity, right? And that's really common for a planet to be like just a little bit bigger. And we would be like, everywhere we walk, we'd be getting crushed, right?
I agree with you.
Yeah.
But I suppose that's not the point. It's about ideas, isn't it?
Yes, and you know this whole idea where you're just supposed to let the story play out.
Yeah. Well, I mean, Sunshine was, the premise is. I mean, the premise is the sun is dying, and we're going to go and fix it.
Yeah.
So both of those things, it fails on its first line a bit in terms of realism. But the idea is that it's not about that. It's about the sun as a god in some ways. It's about our response to the power of nature, and it's about deifying this thing and worshipping it, and how ultimately you go mad. If you remember the film, there's Pinbacker, who's the first captain that went to the first mission to go and restart the sun, which is the mad bit, but then became a religious fundamentalist and then decided. It's a fascinating idea that he decides that to bring meaning to his life, he will become the last man, the last human. And so he wants to be the last. He wants the sun to die, and he wants it to take humanity with it. And he decides to make that happen, so he stays there, waiting for the second ship. And I like those ideas that, what's your reaction to the power?
Sorry, excuse for gonna let that slide.
It's one of the things I do in my shows. I'm not being a commercial person. I just thought one of the great things about cosmology is that it is terrifying in the truest sense of the word. The size and scale of the universe, and black holes colliding and those things. You know, it is very frightening, but also I think the act of trying to understand our place in nature and the size and scale of the universe and our tiny presence within it is valuable. So that you can be terrified but also inspired and interested. And it's part of, if you want to ask questions about what it means to be human and means to be alive, then I'm going to find the answer, which is powers in the universe that we cannot comprehend, as you said. But that's what you've got to face. Because that's what and it sounds
we need that suspension of disbelief in order to sort of you almost have to like go, well, this is really how it would be, but this is how you have to make it in order to fit it into a 2-hour movie.
Yeah, and then the film, like, Sunshine becomes about. Then you can have the film about something else
Yes.
because it's not really
Yes.
about that.
Well, did you like Event Horizon?
Yeah, I did actually. I thought that was
fun,
quite a
right?
cool film. Yeah,
Ridiculous.
I haven't
but,
seen it for
but fun.
years.
I always wanted to ask about their concept of propulsion. That almost like space would be flat, you would fold space over, and you would intersect those 2 points, and you would be able to travel fast distances instantaneously. Right? I'm not doing a terrible job of it, I'm sure. But
Close to the
is
sun.
that a concept that people have actually considered?
Yeah, you can in general relativity. So Einstein's, I should say what it is. Einstein's theory of general relativity is our best theory of space and time, and so it really is. We talked about before. You imagine space and time as a sheet. Just imagine it as a thing, sort of literally a sheet, a surface. And all the theory says is that if you put matter and or energy into that, then it curves it, distorts it, and you can stretch it and make it shrink. And so it's the response of space and time to matter and energy. So if you the simplest version would be the sun. So you put the big spherical ball of stuff in there, and it warps space and time such that the travelling line-of-term business through that warp space turns into an orbit.
And that's why you can actually kind of see things that are behind the sun?
Yeah.
Okay.
So light bends around the sun because it's just travelling through the curved space. The Earth goes round the sun because it's just rolling line-of-term business through the curved space. So an example would be, you might say, well, how does curved space, how does force? So the best analogy I know on the surface, if you stand on the equator of the Earth and you with your friend and you say we're going to walk due north, so we're going to set off, let's say we're 1,000 miles apart on the equator and we're going to walk due north. What's going to happen? So you walk in straight lines, you don't change direction. But the straight lines are the lines of longitude. So as you go further and further north, you carry on to bump into each other. But nothing's happened. And there's no forces acting. It's just that you're moving on a course, so you get closer. And that's basically Einstein's theory of general relativity. Now, why did I start talking about that?
Event Horizon, the idea of
Oh yeah. So all you have to do to those folded kind of geometries is you have to try and specify where you would put the matter and what kind of stuff you'd put there to make the geometry fold in that way. And you can do it. So you can write down that geometry. It's called a warp drive geometry, I think it's called. It's in textbooks. So you can do that to have a warp drive. The question becomes, what sort of stuff would you have to actually put into the real universe to make it warp in that way? And it usually turns out that stuff doesn't exist. Right, but it has properties. It's a sort of matter or sort of energy that has properties that do not exist in nature, as far as we can tell. But you can still write the geometry in Einstein's theory.
So if you had
the
significant
stuff,
force or mass or whatever it is, if you had that stuff that doesn't exist, it is.
Yeah. So the geometry, you can do it, and you can do the calculations, and you can see the warp drive. You can construct wormholes, connect regions of the universe, which you could use as time machines. You can do all that in the theory, but in nature, you'd have to have the right stuff to do it.
But that stuff. You would have to have enough power or mass to be able to fold over.
It tends to be weird stuff that has negative pressure or something like that. So stuff that has physical properties that are just bizarre, and that no matter or energy that we know of in the universe has. So to make the geometry.
But it's conceivable in theory that this could exist, even though it doesn't.
It's a debate ultimately. So wormholes are a good example. So that would be quite literally. We've talked about the surface of the Earth. So you can fly to Australia from LA and you have to go quite a long way around the edge of the Earth, or you could tunnel straight through and get there quicker, right? So you
There we
can.
go.
That's a wormhole.
Jamie's got a little graphic.
There it is.
screen for
There's a
us.
wormhole. So you could go all the way around the edge, or you could take the shortcut. So the question is, so you can do that in Einstein's theory. You can write down that geometry, and there it is. So the first question is, can you make it? And as we said, we don't think that stuff exists.
Right.
There's a second